Welcome to STEM Communication. You've signed into this class so that we can learn together how to communicate our science, whether we are in computer science or whether we're in biology sphere. How can we communicate better to the people that need to learn what we're doing? One of the most important things we have to do with science communication, STEM communication in general, is we need to learn how to get other people to understand where we're bringing value to the society. In order to do that, there'll be two people helping you along for your learning. One is me. My name is Stu Tobit. I am a faculty in biomedical sciences. I'm the department head in biomedical engineering, biomedical and chemical engineering. And most of the things that I do relate to molecular and cellular tissue engineering. You'll also have Megan Hollis helping along with giving you direct instruction on the specifics in trying to make your communications more readily available to the greater number of people. She's been doing this for at least 19 years in sort of helping with students with English as well as communicating in very different ways. Why did we create this course? We created it because we've seen lots of people over time present at national meetings, international meetings, even local meetings, in communicating in ways that actually confuse more people than actually clarify what they're doing. We have people that get into the middle of trying to explain what they do and get all confusing to the point where they can only talk to somebody who's an expert. And 9 times out of 10, if not 99 times out of 100, you're never talking to somebody who knows exactly the same things that you do. So you spend a lot of time on growing what you're going to do. You spend a lot of time in laboratories, in computer labs, wet labs. You ultimately have to figure out how to get across what you spend all those hours doing to other people. If you don't have effective communication skills, it's not going to work, right? So the goal of this class is to actually give you the tools to make it work. We're not going to have you do anything other than work on the kinds of experiments and communication that you actually do in your everyday work life. It's not a matter of learning how to do anything out of a book. It's learning how to communicate what you actually do in a laboratory on a regular basis. In order to do that for this course, we have a bunch of deliverables that you'll be responsible for turning in. One is you're going to turn in a mission statement, an elevator pitch, and strangely enough, a scientific version of a haiku. You will provide a personal statement at some point. Personal statement, something that you do all the time when you actually have to create either biosketches for grants, personal biographical sketches, or biographical paragraphs before you give a talk at a national meeting, ways in which you might actually write a personal statement as a job application. So lots of ways in you have to write personal statements. We'll have you write one pertinent to you as part of the course. You'll have to write a little bit of a short scientific report, not anything that's pages long, 1 page or less, but basically an example of how do you communicate your science in a really short form to get used to not using jargon, which we'll talk about in a little bit. Also, in terms of presentations, a lot of the times in the scientific world, you're actually presenting things in a poster format. It's a very different format than giving talks. We're going to cover both posters and screen presentations and how you can more readily create a visual and text to match that will actually get your ideas across in a simple, efficient manner. We'll do this, and at the end, we'll repeat a little bit of what you've learned from the mission statement and the elevator pitch so that you can pitch your conversation about what you do to somebody who will be taking the course with you. During each of the modules, as you notice, there's 5 modules in here. In the first week of the modules, you're just going to actually explain some of the key components. And they'll let you know what the deliverables are. In the second week of each module, you get to practice what we're trying to talk about in the videos that I will prepare for you. In the third week, then we're going to try and get to the point of having feedback. So we'll introduce what you're going to do. We'll let you do it, and then we're going to come back and take a look at how do we look at that from how effective were you in terms of getting that to work. So we'll do that for personal statements, short scientific reports, posters, and screen presentations. The focus is always going to be on improving your communication skills using your own topics, not anything artificial, but something that you're actually working on, right? So you're going to have to come up with those deliverables so that they're most effective for you, right? And all you really have to do is make sure that you get the deliverables done. It's not where nobody's going to evaluate you on how good you are. Are you the world's best communicator, or do you just simply better at the end of the class? That's really what we're looking for, so that you will come out of this semester that you're taking this, and you're better than when you came in. You'll get feedback from both myself, from Megan, and from the peers that are doing this with you. Right? And by the end of that, you should be able to be significantly better at communicating your ideas. In the world of business, they talk about pillars that actually make business run around the planet: people, profit, and planet. In science, a number of years ago, I ended up deciding that the way that we think about this in science is more along the lines of publish, present, and propose. Whether you're in industry or you're in an academic lab, these are the three things that fundamentally you ultimately need to learn how to do. If you put them together, you end up in a situation where you can have success that can come out of that. So it's challenging to do each of these three. They all have different problems associated with them, but those are the kinds of reasons that you ultimately want to get your language and your communication better so that it can reach a larger number of people. For presentations, it's awkward if you're not used to sitting up or standing in front of a group of people. You're in front of the stage usually by yourself, and a screen behind you, maybe even 2 or 3 screens behind you. So all of those are very awkward, particularly when you look out and see an audience of hundreds, maybe 1,000 people, and they sort of hard to see individual faces and hard to get individual feedback from that kind of a crowd. If you're not doing that kind of a presentation, but rather one in posters, you can see this is a meeting that I attended a number of years ago. And there's, in this particular meeting that's attended by 30 to 35,000 people, there are lots and lots of posters. In fact, 16,000 posters given over 4 days, in which a poster is never up for more than 4 hours. To make you create a poster that can actually work in that kind of format, there's a lot of things that you have to learn about. How do you create visuals that attract people to come to your poster? You want people that are looking you up in the program, but you also want people that'll walk past your poster that's titled in a particular session, and they notice yours more than people that are around you. So creating visuals that are attractive, that will get people to pay attention to your poster, that pay attention during your talk, that they're not looking at their phone. Those are the challenges that we have to reach in presentations. When you're doing publication, we have other problems, right? Even coming up with a title for a article can be hard. Whether or not you want to try and come up with a title that is a riff off of a movie like the one on the left, Live Long and Prosper, comes from Star Trek, or you want to try and come up with something that sounds cute, like the ABCs of experimental evolution. Except for you have to remember, in this particular case, the first author, who's a good friend of mine, created that title without thinking about the fact that it was going to make people think that it was going to be the simple approach to experimental evolution, when he actually meant it to be an acronym. ABC actually stood for something. And so people have never cited this paper ever since it was published. So if you don't come up with a title that people look at for the right reason, then you won't actually get the audience that you want. You need to make sure that you're not offensive to people. So if the one on the lower left, Ashes to Ashes, may be nice if you're talking about fires, but it's not going to be nice if you're talking about children. And the one on the right that you can see on the bottom, there's a typo in that. I will let you take a look. You can pause if you want, and then take a look and read closely as to what's in the title and understand why the authors, once they publish this, wish they could retract it. Retractions in this particular century are not as simple as it sounds. You can issue one, but it doesn't actually change what was originally put out on the internet. Challenging, particularly if you look at the title on the left, which is full of acronyms. Again, we'll talk about how evil acronyms can be. I get emails and letters all the time from people that use acronyms, or even I have to look them up, even when we're in the same field. So you want to get used to the fact of trying to make your communication accessible to as many people as possible. Sometimes we try and use humor inappropriately. This may be not as appropriate in computer science, certainly inappropriate in the world of biology and medicine. In this particular case, this refers to the names of genes that were used that ultimately can be associated with diseases. And nobody wants to hear that they have a disease that's due to a gene called sonic hedgehog. It's one of the worst ones I know. When you propose, it's also important that you get your message across to people that are non-expert, because the people that review your proposals are frequently not experts. Sometimes they're members of Congress, sometimes they're members of the public. If you don't explain your proposal to people in language that's really simple, then they won't appreciate the value of what you want to do and get across to the greater good. And that comes down to money. One of the simplest things that people mess up when they write proposals is that they put it in a format that's really, really hard to read. In this particular example on the right, which is from a grant that I wrote with a friend of mine, you can see a lot of things. One, it's block text. It's very hard to read. There are only spaces in here or barely separating paragraphs. And the figure in the lower right is actually particularly difficult because the font size, which is regulated in most proposals that you will submit, the font size in the figure is actually way smaller than the font size in the actual text. You need to make sure that when you create figures, you're not creating figures that can only be seen when they're on a large screen someplace. And large screens, even in this century, cannot be blown up, or the images on a large screen cannot be blown up beyond the level of resolution. So you end up with pixelated images if you blow them up too far. So whether or not you're doing publications, presentations, or proposals, in all three, you need to actually get them right in order to be successful in what you do. Writing doesn't have to only be for the purpose of success. In this particular case, here's a writing exercise by a student of mine a number of years ago who actually used it because it made him feel better about what he was doing in the lab. It was an idea that my postdoc advisor and I used to talk about all the time, that science goes around in circles, except for because of time, there are actually more spirals. And so it's an idea you can think about that you might come up with in 2020, whatever, anywhere in this decade, where the idea actually came up 100 years ago, but they didn't have the way to do it. They didn't have computers. They didn't have the kinds of access to processing or even the tools that you might use in this decade. And so you can think about, well, how would you write about that? And how would you submit it someplace? In this particular case, he submitted it to 3 journals. 2 of them rejected him, but he actually got it accepted into Science. So here at CSU or wherever you're located, you can do things that will make your imagination run in what you like to think about and still get it as a publication that can actually add to your success. This is a video that talks about sharing ideas, and it's really important to think about what it is about an idea that other people will jump into. At this point, you can easily pause the video you're looking at now, open up the video that you see in front of you. It's a link to a TED Talk given by a number of years ago by Chris Anderson, who was a leader in getting people signed up to do TED Talks. And I think it will be particularly illuminating for you to think about. Another person who was particularly informative for coming up with how scientists can communicate ideas is a guy named Randy Olson. And Randy, this is not his first book. He was a biologist, basically a zoologist at the University of New Hampshire. He was in fact tenured at the point that he got interested in learning how to communicate better. He left his tenured position at the University of New Hampshire, went and enrolled in a film school in LA. And when he came out of the film school, his biggest goal was creating documentaries. But at the same time, he wrote a series of books, this being one of them, on how scientists could communicate by using a scientific method that would make it easier, so that we wouldn't have to turn into being storytellers as much as we can sort of use a formula for communicating the idea and where it came from and how do you solve problems. Right? So rather than telling a story where you basically go, I did this, and then we did that, and then somebody else did that, which is frequently what happens when we give lectures. The practice that he came up with is one that he distilled from analyzing a bunch of stories across history in which they all start with the "and," but there's a problem, and therefore there's a solution that comes about. And so this basically equation of and, but, therefore is a way to, as a scientist, think about how you would tell a story in a very easy manner. The example you see at the bottom of the slide basically says that you can study something over and over in two different ways, but in more years that the way people think about they want to solve the problem has to go to a different level, and therefore you investigate different problems in a new way. That can be applied to whether or not it's a senior design problem in engineering or whether or not it's a particular scientific article you're about to write. It's a way to create the idea as to what started you, what was the problem, and then what was the solution that the paper's about. When you think about all the different ways that we have to communicate, there are lots of different things that go into it, whether or not it's talking one-on-one to a person, whether or not you're teaching in front of a group of other people in a company or in a class, or whether or not you actually are writing it out so you're communicating it in scientific publications, cover letters, grants, things that we'll talk about later in other videos for this particular course, or whether you're using it as speech, that you need to give a talk at a conference, a seminar, or whether or not you're doing it as a job interview. All of those are communication mechanisms that require you understand how do you get your listener engaged. And that's where thinking about these things as stories is really valuable. The biggest enemy you're going to have for the semester is, or through the time it takes you to finish this course, is jargon. Jargon is, for the most part, as you read at the very bottom, it's evil, but functionally, it's something that you actually use on a regular basis. You use it because it's language that makes it easier for you to communicate faster with the people you're working with. And that shortcut is great for the people you're working with, but that shortcut is horrible for the people that are not in the people next to you. If they're not in the company that you're in. If they're in a different division of the company, they might not understand it. So depending on your audience, jargon for one person might not be jargon for another. In order to make sure that you communicate to everybody you talk to, the clearest thing that you can do is just use less specialized language when you have the time. Enjoy the fact that time allows you to be really clear with what you want to do and try and avoid jargon as much as possible. So success in this course simply means that you've gone through all the material, you've learned how to use it, you complete the deliverables, you engage with it, and put those in a form where the communications that you do at the end of this are simpler and more effective than at the beginning of this. And so as long as you edit and revise your work, you pay attention to the feedback you get from Megan, myself, and your peers, then I think this course will be very valuable for you to improve what you can do for the rest of what you do in science and engineering.